Our next topic is time series data. It is really important because often time series data can get complicated and a lot of things are happening in a graphic. So there's a lot of ways that we can handle this kind of data. So for example, in the Gapminder data, a lot of our time series is grouped, in this case by country. We've seen this plot a lot. This is very common for time series, that you have data across multiple units or entities over time. To make sense of a lot of lines, one important thing that we can do is we can control where the focus goes in this. In our previous plot, we essentially just leave it up to the reader to ask some questions about what they're seeing. We see 2 outlier countries that are growing, and then we have a ton that are just kind of stacked on top of each other. It's hard to really get a story out of this one. So one thing that we can do is we can call out a single country, for example. And in this case, we're going to grab Gapminder and then make Mexico versus world, which is an if-else, where if it's a country is Mexico, then label it Mexico. Otherwise, label it the world. So this is going to allow us to say this is what Mexico is doing, and then we can do something else with the rest of the lines that represent the world. From here, we can say we want X to be our x-axis, Y to be GDP. Group is by country, so we want each line to still be by country, but we want it to color by this Mexico world variable. We also want the alpha, so the transparency itself, to be by Mexico versus world. We're going to see what that looks like. So far, we've just hard-coded alpha levels, but in this case, we can also do it by a grouping variable. And we add geom line, and then we're going to do some color and alpha scales. For color, we're going to say I want the values to be black and light gray. So black is going to go with Mexico, light gray is going to go with world for those 2 levels, as that is our coloring variable. And then alpha, we're going to have values of 1, which is no transparency, and 0.4, which is 60% transparency. We're going to log 10 the Y scale and give it a dollar label. Going to use the BW theme. Going to put the legend at the bottom. And then we're going to give some labels. Notably for color and alpha, we are going to just leave the label blank. So what does this produce? Well, we get Mexico as a dark color and world as a lighter color. And now already we're pulling out information to show where does Mexico fit in with the rest of the world. We can see the rest of the world's trending patterns, and we can see, oh, this is where Mexico fits in. So that was a pretty simple situation with time series. Often there's more complicated ones where it's not just by year over a handful of countries, but instead it's every minute or every second for years kind of data. What we're going to use here is a Sybil package, a T-Sybil, and we're going to use a large data set called NYC Flights 13. What we're going to pull out of that package is the weather data. So here we're going to call it weather. We're grabbing from within this package, we're grabbing the weather data object, selecting a few of the variables, and we're creating a time series with it by telling it what the key is, in this case, the origin, and the index, which in this case is a time hour. What this produces is a Sybil, similar to a Tibble, that tells us it's 26,000 lines long. The key and the origin. It tells us information about what it understands as a time series. What is the key and the index for us? And then our additional variables are the temp at that time, the humidity, and the precipitation at that time. What's great with a Sybil is we only have to give it a little bit of information and we can start getting some information out. Here we're using our weather object. We're telling it our X is time and hour, Y is temp, group is origin, which is the airport of origin, and then the color is also origin, and then we do a geom line. This produces this, a lot of overlapping lines. These airports are not terribly far away from each other, and so there's a lot of overlap in the temperature on the same days for them. We can clean this up quite a bit. First, we're going to keep all the code up to this point the same, but now the geom line we're going to make 50% transparent. We're going to give it some better colors. Another color palette I really like is this magma one from the Viridis color palette. We're going to use theme BW, and then we're going to give it some labels. This already is a little bit better. Still just so much overlap that it's hard to distinguish between them, but the message is clear. It's cold in the winter, hotter in the summer for these airports. Now we can go further and we can decompose this time series so we can understand it in more detail. If you're working in finance or other related fields, these are things that you for sure have done. We're going to use some really cool packages to make this as easy as possible. So the first one we're going to use is FEAS. FEAS is going to help us extract a model, and we're going to be able to use that to plot more of the information that's housed in this time series. So one of the things to note here is we're going to end up using a function called autoplot. This is still a ggplot object, but autoplot's going to take away some of the work for us. It's going to look at the data that we prepare, and it's going to create a ggplot for us. So if we want to make changes to it, we always can do a plus and then make changes to it just like we do on any other ggplot. Here we're going to start with our weather object. We're going to fill in the gaps for precipitation where there's gaps in the precipitation variable, or in other words, there's missing data for it or other things. We're going to add precip equals 0, so it's going to fill in where it doesn't know what the precipitation was, and we're going to assume that it was 0. We're going to group by key, which is a function that looks at the Sybil with the key already there, and it's going to assume you want to group by that key. We're going to fill in any missing data with a previous temperature or humidity value. So we're going to assume if it's missing that if we can just use the previous temp as a rough approximate for what it should be. The last thing we're going to do is we're going to use the model function from FEAS. This is going to give us an ability to model the data, and we don't need to go into all the pieces of the model, but essentially we're just saying there's seasonality to this model, so please model away what's just seasonality and understand more about what is happening in this data. Lastly, we're going to use components on this data object, and we're going to put that into autoplot. So this gives us a lot of information really quickly. And again, this is a ggplot that we could make changes to using plus, and then we could change a theme and other things. First, this is the raw data showing us the temp changes over time. We can look at the trend. So this smooths out the up and down. We can look at different other pieces taken out, including the remainder. Is taken out. So this is just what is left over after we take the trend and other seasonality pieces out of or our daily pieces like the high and low temperature of each day. This is what's left over that the model doesn't know just based on the time and hour and origin. With this, we also can create forecasts. There's a larger tidyverts group of packages that Sybil and Feast also belong to. So if you want more information on forecasting or decomposing time series, I totally recommend looking up tidyverts. It is going to have a bunch of packages that help you out. Here we're going to load the Fable package. We're going to prepare our data, very similar to what we did before, filling in the gaps and the missing data. We're going to make a model. So we're going to look at the data. We're going to create an ARIMA model here. And we're going to forecast a month out. So all of this stuff is going to come from the tidyverts group of packages. And ultimately, it gives us a model in order for us to plot. Last thing we're going to do is use autoplot, again, which is a ggplot object underneath the hood. We're going to give it the model and our data. And it's going to create this for us. It's going to look at each origin, the temperature changes over time, and then it's going to predict, based on the model, based on this data, what is the likely temperature going to be over the following month. It gives us a couple levels, including 95 and 80% confidence intervals for that prediction.